In the previous video, we talked about how the first step in artificial intelligence is to define the problem at hand using the PEAS acronym. So the performance measurement, the environment, the actuators, and the sensors. And then we said we're going to be solving this problem using an agent program. So this agent program could be implemented using one of those four models. The first one is the simplest, and this basically just says that we're going to observe the environment, and we're going to have, for every possible observation, we're going to have an associated action. So this is very simple. You just have if this happens and therefore do that, if this happens and therefore do that. This is a very simple algorithm to solve the problem. The second one, the model-based reflex agent, basically admits that we don't really have a grasp of the full environment around us, and we're going to have to find approximations to it. So it creates a certain state here. So based on the observations that it receives from the sensors, it's going to create a state over here that approximates the environment. So we're going to be like, given those facts that we got from our sensors, we believe that we are in such a state. And this state will be constantly updated, and then based on that state we're going to have an action. So we realize that we don't have all the facts around us, and this is of course closer to reality than this model. Third model is the goal-based agent. The goal-based agent, in addition to defining a state, will also define a goal, and this is of course important for any artificial intelligence problem. So you have one goal that you're trying to achieve, and every time you're at a certain state, you're going to look at that goal and see, okay, what should I do to achieve that particular goal? So this is the goal-based agent. And finally, we have the utility-based agent. We extend the goal-based model, and we say that there could be many paths to achieving this goal, and we're trying to find the most efficient one. So we're going to be defining a utility function which gives us scores for every single path, and based on these we're going to choose the one that maximizes our performance and our ability to choose this goal. And finally, there's one component that could be added to any of these models, and that's the learning component. It enhances the model because the robot or the artificial intelligence agent starts learning about its environment and modifying this entire process.